Imagine everything you love and know, every person, every city, every memory, squashed into a pale blue dot. That's Earth, seen from the Voyager spacecraft. Now buckle up because we're about to zoom out. We're going from the Moon to the Sun past Mars, and Neptune catching up with Voyager, and then pushing out to the Oort Cloud Alpha Centauri across the Milky Way, and all the way to the edge of the observable universe. By the end of this journey, you'll feel both incredibly tiny and, strangely, very powerful. In this video, you'll learn the real distances between the places we talk about in space, but in ways you can actually picture. Why does this matter? Because understanding scale changes your perspective. It shows just how fragile our home planet is, how ambitious our space exploration needs to be, and why our radio signals, our whisper into the void, haven't reached most of the galaxy yet. This isn't just about numbers. It's about understanding our place in the cosmos. Ready to have your mind blown? Let's begin. First stop, our cosmic neighbor, the Moon. It's about 384,000 kilometers away. That sounds like a lot, but what does it mean? If you could drive there in a car at a steady 100 kilometers per hour without stopping for gas or bathroom breaks, the trip would take you more than 160 days. From the Moon's surface, our Earth hangs in the black sky like a fragile, swirly blue marble. It's a view that has changed every astronaut who has seen it. Next up, the heart of our solar system, the Sun. We measure this distance in a special unit called an astronomical unit, or AU. 1 AU is about 150 million kilometers. The light from the Sun, traveling at the fastest speed possible, takes 8 minutes and 20 seconds to reach us. So when you look at the Sun, don't actually look at it. You're seeing it as it was over 8 minutes ago. If you wanted to fly there in a commercial jet, traveling at about 800 kilometers per hour, it would take you around 19 years. 19 years just to get to our own star. Now let's head to the red planet Mars. It's the next logical step for humanity, right? Well, the distance is tricky. At its very closest approach, Mars is about 54.6 million kilometers away. But when it's on the far side of the Sun from us, that distance balloons to over 400 million kilometers. Even with our fastest rockets, a one-way trip takes months. If you tried to fly there in that same jet, you'd be looking at a journey measured not in years, but in decades. These staggering distances are what make missions to even our nearest planetary neighbors both heroic and incredibly complicated. Now we're leaving the cozy inner solar system and heading for the giants. Let's leapfrog out to Neptune, the farthest known planet from the Sun. It sits about 4.5 billion kilometers away from us. Sunlight, which took just over 8 minutes to get to Earth, takes over 4 hours to reach Neptune. The planet is a dim, distant world, so far away that it looks like just a tiny blue star from Earth, even with a good telescope. And what's even farther than Neptune? A piece of us. The Voyager 1 spacecraft. Launched way back in 1977, it's now the farthest human-made object from Earth, over 22 billion kilometers away and still going. It's in interstellar space, beyond the influence of our Sun's solar wind. Remember that famous pale blue dot photo? Voyager 1 took that picture from about 6 billion kilometers away, turning back to see our world as a single pixel in a sunbeam. That one image completely recentered how we see ourselves and our home. But the solar system doesn't just end there. Beyond Voyager lies a theoretical, ghost-like shell of icy bodies called the Oort Cloud. We've never seen it directly, but we think it's out there. This vast sphere is thought to start around 2000 AU from the Sun and could stretch up to 100,000 AU. That's almost 1.9 light-years away. The Oort Cloud is the last frontier of our solar system before we truly enter the vast emptiness of interstellar space. Wait till you hear this next part. It's a real mind-bender. How can the universe be only about 13.8 billion years old? but span a distance of 93 billion light-years? That twist is coming up, and it explains everything about cosmic expansion and why some galaxies are already out of our reach forever. So, we've crossed the Oort Cloud. We are now officially between the stars. Our nearest stellar neighbor is the Alpha Centauri system. It's about 4.4 light-years away. That doesn't sound too bad, right? 4.4, but a light-year is the distance light travels in a year, which is about 9.5 trillion kilometers. So Alpha Centauri is around 41 trillion kilometers away. To put that in perspective, if we sent our fastest probe, Voyager 1, on a direct course to Alpha Centauri, the journey would take it tens of thousands of years. This is why astronomers switch from kilometers, or AUs, to light-years. The numbers just get too ridiculously large to be useful. These colossal distances are the single biggest reason why interstellar travel remains a monumental challenge, firmly in the realm of science fiction. For now, let's zoom out even further. We're now looking at our entire home galaxy, the Milky Way. It's a beautiful spiral galaxy, a swirling city of stars, and it's roughly 100,000 light-years from one side to the other. Our Sun is located in one of its spiral arms, about 27,000 light-years from the galactic center. Now think about this. We've been broadcasting radio signals for about 100 years. This creates a radio bubble around Earth that is about 100 light-years in radius, or 200 light-years across. On the scale of our 100,000 light-year-wide galaxy, our bubble is an insignificant little speck. Any civilization on the other side of the Milky Way would have no idea we exist. But the Milky Way isn't alone. It's part of a galactic neighborhood called the Local Group. This group contains over 50 galaxies, including the giant Andromeda galaxy, and spans a region of space about 10 million light-years across. Zoom out again. Our local group is just one small part of an even bigger structure, the Virgo supercluster. This massive collection of galaxy groups and clusters spans about 110 million light-years, and even that is just a lobe of a grander structure called the Laniakea supercluster, which our galaxy is a part of. Laniakea stretches for an incredible 500 million light-years. And now, for the final zoom out. The edge of the observable universe. The farthest light we can detect has traveled for about 13.8 billion years to reach us. But here's the twist I mentioned earlier. While that light was traveling, the universe itself was expanding. The space between us and that distant galaxy stretched. So that galaxy is now much farther away than 13.8 billion light-years. The current estimated diameter of the entire observable universe is about 93 billion light-years. And because space is expanding, some of the most distant galaxies are receding from us faster than the speed of light. We will never see them. Their light will never reach us. They are beyond our cosmic horizon, lost to us forever. So after this journey from our moon to the edge of everything, what's the big takeaway? We are unimaginably small, living on a fragile dot in a vast cosmic ocean. But that same smallness makes our curiosity and our technology even more incredible. Our ability to understand this scale, to map the cosmos with our minds and our instruments, allows us to reach farther than any other known life in the universe. We are the universe's way of knowing itself. If this journey through cosmic scale humbled you, hit that like button. And I want to know your thoughts in the comments. Would you be willing to travel to Mars, even knowing it could be a one-way trip, or take a huge chunk of your life? Let me know what you think. And if you want more journeys through space, science, and the stories that change how we see ourselves, make sure you subscribe to InfoSpark Zone. Thanks for watching.